Have you ever been confused by a simple sentence? Imagine your friend says, "I saw the man with the telescope." Did they see the man who was holding the telescope? Or did they use a telescope to see the man? Language can be tricky, and that's where ambiguity comes into play. In today's video, we're going to dive deep into ambiguity resolution in natural language processing, or NLP for short. This is especially important for students and tech enthusiasts curious about how machines understand language. Understanding ambiguity helps us improve applications we use every day, like chatbots, translation services, and even virtual assistants. Let's break it down step by step. First, let's talk about the nature of ambiguity in human language. Human language is complex, often relying heavily on context to convey meaning. One word could mean multiple things depending on how it's used. Take the word light. It could mean the brightness in a room, something that isn't heavy, or even a color. This illustrates how important context is when interpreting language. Next, there are different types of ambiguity that NLP systems must deal with. Let's explore these categories one by one. The first type is lexical ambiguity. This is when one word has multiple meanings. For instance, the word bank can mean a financial institution or the side of a river. Yet, without context, we can't know which is meant. NLP systems use the surrounding words to figure out the right meaning. Another example is the word bat. Do we mean the flying mammal or the sports equipment? Moving on, we have syntactic ambiguity. This occurs when a sentence can be understood in different ways due to its structure. The example we started with, "I saw the man with the telescope," is a perfect illustration. It could mean you saw a man who had a telescope or that you used a telescope to see the man. Both interpretations are valid, but they lead to different meanings. Next up is semantic ambiguity. This type of ambiguity happens when a sentence has multiple meanings, even if the structure is clear. For instance, the sentence, "He is looking for a bat," can refer to the animal or the sports equipment. Understanding the context is essential for resolving this type of ambiguity. Lastly, there's pragmatic ambiguity. This involves the implied meanings that depend on social or conversational context. Consider the phrase, "Can you pass the salt?" It sounds like a yes, no question, but it's really asking someone to pass the salt. NLP systems face challenges understanding these nuances. Now that we've covered the types of ambiguity, let's discuss the challenges they present. Ambiguity resolution is a significant challenge in NLP. If machines misinterpret language, outputs can become inaccurate or even nonsensical. This is particularly problematic in machine translation. If a word is misunderstood, the whole meaning of a sentence can be lost. In speech recognition, common pitfalls include homophones like right and right. If a system confuses these words, it can lead to errors in transcription. Also, think about sentiment analysis. Sarcasm can make it hard to determine if a statement is positive or negative. For instance, "Oh, great. Another Monday" is usually meant as negative. So how do we tackle these challenges? Several techniques have been developed to help. First, there's contextual analysis. This involves looking at surrounding words to understand meaning better. For example, if bank is next to money, it's likely about finances. Then we have word sense disambiguation, or WSD. This technique identifies the correct meaning of a word based on its context. Various algorithms can be used for this, helping to pinpoint the proper sense. Another method is syntactic and dependency parsing. These techniques analyze sentence structures to establish word relationships. For example, they clarify who is acting and who is affected in a significant challenge in natural language processing, NLP, as words and sentences often have multiple meanings depending on the context. To interpret text or speech correctly, systems must resolve these ambiguities, which is crucial for effective communication. Here's how ambiguity manifests and is resolved in various NLP tasks. Word sense disambiguation, WSD, helps resolve ambiguity when words have multiple meanings. For example, the word interest can mean both curiosity and financial interest. Context is key to understanding which sense is intended. Anaphora resolution involves resolving which pronouns or noun phrases refer to the same entity in a text. For example, in John put the carrot on the plate and ate it, resolving the pronoun it to the carrot is essential for understanding the sentence correctly. Deep learning and transformer models in ambiguity resolution. As we move forward, deep learning and transformer models have revolutionized how we handle ambiguity. Models like BERT and GPT consider the entire context along with word meanings. They are excellent at resolving ambiguities through self-attention mechanisms, which allow them to understand complex relationships between words in a sentence and decide on the correct interpretation based on the context. Named entity recognition, NER, and ambiguity resolution. One important technique in ambiguity resolution is named entity recognition, NER, which helps disambiguate words. NER identifies specific entities like people, organizations, and locations in text. For example, the word apple could refer to the fruit or the tech company, and NER helps distinguish between these meanings based on the context. Real-world applications of ambiguity resolution. Ambiguity resolution is crucial in various NLP applications. Machine translation ensures accurate translations by resolving word meanings based on context, e.g., bank, as a financial institution or riverbank. Speech recognition resolves homophones, e.g., write vs. write, to improve transcription accuracy. Sentiment analysis interprets sarcasm and tone, ensuring accurate emotional readings, e.g., oh, great, based on context. Chatbots and virtual assistants helps interpret ambiguous user queries, e.g., can you play some jazz? By understanding context and preferences. Information retrieval resolves ambiguous terms, e.g., apple, as fruit or company, for accurate search results. Automated customer service identifies different needs based on context, providing more tailored responses, e.g., I need help with products or account settings. Trees and ambiguity resolution. A syntactic parse tree represents the structure of a sentence, illustrating the grammatical relationships between words. It plays a vital role in resolving structural ambiguity, where a sentence can have multiple interpretations based on its structure. This is common in sentences with multiple potential syntactic groupings, even when the individual words are clear. Example of structural ambiguity. I saw the man with the telescope. The sentence, I saw the man with the telescope, can be interpreted in two ways. 1. I saw the man who had the telescope. The man is holding the telescope. 2. I saw the man through the telescope. I used the telescope to see the man. A syntactic parse tree helps resolve this ambiguity by showing the different ways the sentence can be structured, depending on how the prepositional phrase, pp, with the telescope is interpreted. Here's how syntactic parsing works in this context. In this interpretation, the prepositional phrase, pp, with the telescope, modifies man, indicating that the man is the one holding the telescope. Here, the prepositional phrase, through the telescope, is attached to the verb phrase, vp, implying that the act of seeing was done through the telescope. Role of syntactic parsing in ambiguity resolution. Ambiguity identification. The parse tree explicitly shows the multiple ways a sentence can be structured, revealing different interpretations. Disambiguation. By analyzing the tree structure, we can determine which interpretation is correct based on the surrounding context, thereby resolving ambiguity. Thus, syntactic parsing helps clarify structural ambiguities, ensuring that the correct meaning of a sentence is understood. The same sentence can have different syntactic structures, and the correct one must be chosen based on context, which is a key task in natural language processing, NLP. Conclusion. Ambiguity resolution is crucial for accurate communication in NLP applications. Whether it's through syntactic parsing to handle structural ambiguity, deep learning models like BERT and GPT for contextual understanding, or techniques like NER for entity recognition, resolving ambiguities allows systems to interpret language in a way that mirrors human understanding. From machine translation to chatbots, effectively resolving ambiguity ensures more accurate, meaningful, and useful interactions between machines and humans.